Welcome to Maths with Bob. This is a 3-minute series on statistics. We're looking at confidence intervals actually with the t-distribution at the moment. So we're doing inferences on the mean. Obviously we're using t-distributions because the variance of the population is unknown. Now this is the confidence interval constructor, you could say. X bar plus or minus t n minus 1, which is n minus 1 degrees of freedom, colon, alpha on 2, half up and half down, times s, the standard deviation of the sample, all over the square root of n. That's a sample size, and you see here we use obviously a degrees of freedom 1 less than the sample size here, n minus 1, okay, to give us this little factor here. Okay, so problem 3.4, which is actually just a continuation of problem 3, which is a hypothesis testing. We're actually going to extend it into what's called a confidence interval. Okay, the problem basically was the manufacturer had claimed a breaking strength of 8,000 newtons, but a sample of 6 had a sample mean of 7,800 newtons and a standard deviation of 180 newtons. We have to find a 95% confidence interval of the mean. Now we are doing this assumption of normality actually for t-distributions for all these problems. Okay, so let's have a quick look. Okay, so what do we do? Well, obviously this is the constructor over here. You can see x bar, which we can see over here, 7,800 plus or minus. Now this particular factor, okay, is, you can see here, 2.5%. As the hypothesis testing was only one-sided in the last problem, and we had a 5% value here, but we know we've got 2.5% above and 2.5% below. It's a T5 distribution because there was 6 in the sample size anyway. So let's actually, when we plug all the numbers in, we get 180 on square root of 6. Okay, we're using a T5, yeah, over here, and this works out to be what, 7611 or 7,611.01 newtons to 7,988.91. And you can see here, basically it's not encompassing our mean of 8,000. However, if we do widen it, drop the significance level and widen the confidence interval, we get it from 7,504.37 to 8,095.63. So this one does encompass our manufacturer's claimed mean breaking strength of the rope, 8,000. Okay, and you can see here we're using 2.5% and 0.5% above and below, basically. And you might remember that t-distributions only gave a positive value, so you had to reflect it back to get the negative values. Okay, so actually, what are our conclusions about all this? Well, yes, it's not wide enough. Our confidence interval doesn't encompass our 8,000 newtons. Okay, you can see here 7,600 to 7,988. You can see here this is a 95% confidence interval, and basically the wider one, obviously, you can see we just get in here at 8,000. Okay, but basically what would happen is this is actually too wide. I would be inclined again to look at this one and say, sorry, the rope's breaking strengths basically not up to what you're claiming. Thank you very much for watching. Bye for now.